Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about trigonometry. Now the question that I've chosen to go through here with you is 2018 Paper 2 Question 9. There's a very detailed description at the start of this question, but to go through Part A we don't need to discuss it. In Part A we're simply given this diagram. We're given a non-right angle triangle. You know the angle 15 and the side opposite it, you know the side 30, and you're looking for the angle opposite it. So straight away you should realize I'm dealing with either sine, cos, or you're dealing with either the sine rule or the cosine rule. Now, because you know a side and the opposite angle, the easiest one to use here is the sine rule. You can say that 10 over the sine of the opposite angle, 10 over sine 15 is equal to 30 over the sine of the opposite angle, which is 30 over sine A. If you just multiply both sides by sine A and then by sine 15, or cross multiplying, you get 10 sine A is equal to 30 sine 15. To get sine A on its own, you just divide both sides by 10, and then to get A on its own, you get sine inverse of all of that, and your A works out as 51 degrees. Okay, so for B part 1 now, we need to consider the diagram. So I've taken down the diagram that we have in B part 1. Notice the distance CD is a metal rod. The distance CD is a metal rod, it cannot change, it will always be 30 centimeters. The distance from O to D is another metal rod. It cannot change, it will always be 10 centimeters. The only thing that can change is this theoretical distance between C and the center of the circle. The crank it's rotating around like that. So as it rotates like that, this C is going to move forward and backwards like that. So the D itself is going to rotate around the circle, and as it rotates around the circle, this distance C is going to slide that way and then that way. It's going to slide over and back and over and back. And what we're concerned with in B part 1, we're now given a function. We're told that alpha, this angle, obviously as D rotates, the angle alpha is going to change. Okay, the angle alpha is going to change from 0 up to 360 degrees as we go around this circle. And as alpha change, the distance from C to the edge of the circle, x, the distance cx is constantly changing. It's sliding, because this C it's a crank and it's going over and back and over and back. So we have to determine, as this angle changes, how does the distance from C to x change? That's what we're exploring in the next few parts of the question. The first thing we're asked is to write out the period and write out the range. Now I've drawn two diagrams here that we can think about our range. So obviously I need to find the minimum distance between C and X, and then the maximum distance between C and X. The diagram here, I've drawn down the scenario that would exist if alpha was equal to 0 degrees. So if you imagine if it's just in a straight line, alpha was 0 degrees. In other words, it's done a rotation and it's back where it started. In that case, the metal crank, the distance from C to D is 30 centimeters. And in this scenario, the distance from C to D is the same as the distance from C to X. So in this case, the largest distance that C could possibly be away from the edge of the circle is 30 centimeters. So when you're dealing with your range, your maximum is going to be 30. Okay? To work out the minimum distance, we now need to think about what occurs when alpha is 180 degrees. In other words, imagine if I then I'm sliding C across its metal crank, the connecting rod slides along here and it ends up over there, which is what I've drawn in this scenario. D was there, but it's gone a full revolution, or half of a revolution. The angle alpha is 180 degrees. It's gone a straight angle. I know that the distance from C to D will always be 30 centimeters because it's a metal rod. I know that the radius of the circle is 10, which means the diameter of the circle is 20. If the distance from C to D is always 30, and the diameter of that circle is 20, then clearly the distance from C to the edge of the circle must be 10. So the minimum value that Cx could take is 10. So your range in this case is just from 10 centimeters to 30 centimeters. And the other one then is your alpha, and alpha is relatively straightforward to identify. Clearly this pattern is going to repeat itself every 360 degrees. So the period in this case, you can refer to it as 360 degrees, or you could call it 2 pi, depending on whether you want to use degrees or radians. Okay, in B part 2 of this question, we're now given this table. And we need to fill in the values of f of alpha for the angles 0, 90, 180, 270, and 360. Now in a question like this, it's really important that you're clear on what the function represents. They told me at the start of B that f of alpha is the distance cx. The distance cx is a function of the angle alpha. In other words, cx varies depending on what the angle alpha is. And in B part 1, when we got our range, we know that when alpha is 0 degrees, the distance cx is 30 centimeters. Obviously then the same applies for when it's 360 degrees. When alpha is 360 degrees, it's the same as if it was 0 degrees. So that one's also 30. The 180 degrees, we worked that out in the previous part as well. When alpha is 180 degrees, the distance cx, the distance from C to the edge of the circle, is 10. So the only two then we have to work out are 90 and 270. And you'll see I've come up with a diagram here. This is the scenario if alpha is 90 degrees. In other words, if D started there, it's gone one quadrant, or it's gone 90 degrees to here. If alpha is 90 degrees, the distance CD is still 30, because it's a metal rod, it will always be 30. The distance OD is 10, it's a metal rod, it will always be 10, which now means I can work out the distance from C to O. Because I have two sides in a right angle triangle, we just use Pythagoras to find the third side. So as you can see, I've set that up here. The hypotenuse in this case is 30, so 30 squared is equal to 10 squared plus CO squared. And if you simplify that down, you end up with the distance CO is equal to 28.28. But I'm not looking for the distance CO. I'm looking for the distance CX. So you have to realize that clearly the radius of this circle is 10. So I know OX is 10 centimeters. If the distance from the distance CO is 28.28, I just subtract 10, and I now know that the distance CX will be 18.28 centimeters. So when alpha is 90 degrees, f of alpha is 18.28 centimeters. Now we don't need to bother doing the other diagram, because just think about what would happen if if D continued to go around the circle and when alpha is at 270 degrees, it just goes straight down. You have a scenario like this, and then your tangent is the exact same. That distance would be 30, that distance would be 10, it'd be the same right angle triangle. So the distance when alpha is 90 degrees, f of alpha is 18.28. It's the same when alpha is 270, then f of alpha is 18.28, because it's the same diagram. Okay, so let's move on now and look at the next bit. So once I've B part 2, it's relatively straightforward now. You just plot your points and you draw your graph. So when you plot your points here, I'd label in all 5 points and obviously try and be as accurate as possible. You will have lines, or you can measure this with a ruler. You want to be as accurate as possible, plotting your 5 different points, and you should get the marks. Okay, so for B part 4, we're now told to look back at the start of the question. Look back at diagram 1, 2, and 3. And in which one of these diagrams will a 1 degree change in alpha have the most significant effect on f of alpha? So in other words, for which one of these diagrams will a 1 degree change in the angle have the most significant effect on the distance from C to the edge of the circle, the distance CX? Now you were allowed, there's a space in the marking scheme here where you're allowed to just look at the 3 diagrams and rationalize it. But mathematically, the easiest way to understand it is from the diagram we have in B part 3. Now in the context of this question, you should realize that the change in alpha, the change in f of alpha caused by a 1 degree change in alpha, they're referring to the rate of change. Rate of change usually for you means differentiation. And another thing that differentiation is also its slope. So in this case, you should realize we're talking about the rate of change. So we're actually talking about the slope. So it makes sense in the context of the diagram here. Whichever one, diagram 1, 2, or 3, for whichever one is the steepest, then that's the one where the rate of change is the most significant. I've roughly looked at, for diagram 1, alpha is 0 degrees. And for diagram 2, it looks to me like alpha is about 60 degrees. For diagram 3, alpha looks like it's about 210 degrees. So if we go back to our diagram in part B, part 3, roughly 60 degrees, it's roughly there. Okay, 210 degrees is roughly there. That'll be at diagram 3. That's the point. At diagram 2, that's the point, and at diagram 1, I'm just starting off. So the question basically boils down to at which one of these 3 points, diagram 2, diagram 1, or diagram 3, is the graph the steepest. Because the steeper the graph is, the larger the slope. In this case, obviously the slope is positive. In this case, the slope is negative. So when I say larger, I actually mean the furthest from 0. Whichever slope is the furthest from 0, that's the steepest one. That's where the rate of change is the most significant. Now you should be able to tell that obviously at a turning point up here, the slope is 0. So it's definitely not diagram 1. The rate of change in diagram 1 is very insignificant. The slope down here is also 0. The slope at 180 is also 0. Well, diagram 3 is closer to a turning point than diagram 2 is, which implies, and you can probably tell just from your diagram, but clearly at the point of diagram 2, which is roughly 60 degrees, that is, of the 3 scenarios, that's the steepest slope. So your answer in this case, you should refer to the fact that in diagram 1, the slope, it's at near a turning point, so the rate of change is negligible. In diagram 2, it's quite significant. It's the steepest, and it's steeper than diagram 3. So if you refer to the fact that at diagram 1, the rate of change is quite insignificant because it's near a turning point, and that diagram 2 is steeper, the point of diagram 2 is steeper than diagram 3, that's how you get your marks. So you have to refer to, individually for diagram 1, diagram 2, and diagram 3, refer to the steepness of the graphs, and mention that diagram 2 is the steepest of all 3. Okay, so for the last part now of question 9, we're dealing with a completely different diagram. And here we're just going back to basic trigonometry. You're given the distance AB is 36, the distance AX is 31, and the angle between them is 10 degrees. I know that OB is the radius, and obviously OX is also the radius. So in this case, I've been asked to find the distance OR. What you need to view here is that we more or less have two sides in the angle in between them. We just don't know that entire side AO. But it's a non-right angle triangle, so it's either sine rule or cosine rule. And in this case, you have 2 sides and the angle in between it, so you're going to be using the cosine rule. So I'm going to sub into a squared is equal to b squared plus c squared minus 2bc cos a. Clearly in this case, the angle that I'm dealing with is the 10 degrees. So my a is going to be 10 degrees. So that's going to be my cos of 10. If that's my 10 degrees, then the side opposite it needs to be the small a, this side on its own. Opposite the 10 degrees is OR. So that's going to be OR squared, which is equal to one of the sides, which is 36 squared, and then C in this case is going to be 31 plus OR. So C is 31 plus OR to be squared. And it's minus 2 times B, which is 36, C, which is 31 plus OR times the cos of A, which is the cos of 10. Now at this point you've one equation, you've one unknown, which means you can find the value of your OR. Now I want you to try this yourself and then I'll go through it. Okay, this is quite a complicated solution, so let's go through it in detail. We subbed into our cosine rule, and we just get OR squared equals 32 squared plus 31 plus OR to be squared minus 2 times 36 times 31 plus OR times the cos of 10. What I've done on the next line is I squared 36 and I multiplied 31 plus OR by 31 plus OR, and you get these 3 terms. Okay? And also I've multiplied, notice I've multiplied minus 2 by 36, which gives me minus 72. It's this last term that's going to catch a lot of people out. So I've multiplied minus 2 by 36 to give me minus 72, and then all I've done is rearranged it. I'm putting the cos 10 in front of the 31 plus OR. So I've just written it in a different order. Minus 2 by 36 is minus 72, and then I'm just writing the cos 10 ahead of that bracket. The next thing on the next line, I noticed I have an OR squared on the left and an OR squared on the right. So I brought one of my OR squareds across so that they're going to cancel for me. I added the 1296 and the 961 to give me 2257, and then I have plus 62 OR. Now my OR squared is gone because I brought it across. What I've done here, now you have to be very careful here. I've got minus 72 cos 10 and I multiplied it by 31. and I get minus 2,232 cos 10. Basically, I've just multiplied the 72 by the 31. Then I have to multiply it by the second thing in the bracket, so it's minus 72 cos 10 by OR, which just gives me minus 72 OR cos 10. Now on the next line, my OR squared is cancelled, so my left-hand side is just a 0. And I've 4 terms on the right-hand side, and all I've done is I've grouped the terms, the actual numbers, and then the terms with ORs in them together. Now these two terms are just numbers, so I brought them to the left-hand side. I get minus 2257 plus 2232 cos 10. And on the right-hand side, I've got 62 OR minus 72 OR cos 10. Now on the right-hand side, you have to factorize out your OR, because obviously if you're trying to solve for OR, you want to have only one OR in your equation. So I factorize out OR, and I'm left with 62 minus 72 cos 10. At the same time, on the left-hand side, I've just plugged all of these numbers into my calculator. I got minus 58.909. So at this point, you should recognize that in order to get OR on its own, you just want to divide both sides by this bracket. If you divide the right-hand side by the bracket, you just get OR. If you divide the left-hand side by the bracket, you just get this fraction. Now I'm happy out. I've got OR on its own, and these are all numbers, so I can just plug them into my calculator, and I get OR is 6.61442. But the question asked you to leave it to the nearest centimeter, so your final answer is that OR is equal to 7 centimeters. Okay, so that's it for 2018. I hope that video makes sense. If you're unsure of anything there, then just let me know in class or send me an email, and I'll try and explain it a little bit differently.